the customer has complained that this PCB is completely dead. So this is a refrigerator PCB which has been installed to run a Panasonic compressor. Now with this PCB, as you can see, I have attached the compressor so that we can check whether the compressor starts or not. So first of all, we will supply power to it. Or, this is some number of this PCB, and I have applied power, and here the voltage is. This is showing very low voltage. Look, 3.39 volts are coming on it, which is completely wrong. Why is this happening? Alright, let's do this. Now we remove the compressor wire. Now I will check it by supplying power. Turned it on. Still, as you can see, 2.4 volts, 3 volts, something like this are coming. And look at the hertz. It is exactly 50 hertz. Now, these voltages become faulty only when there is some kind of short circuit. Then this problem occurs. I turn it off. And along with this, what I will do is connect my probe with the line and also connect it with the neutral. So what we will do is confirm whether our power supply is correct or not. Sometimes it is necessary to do this so that if there is any mistake, it comes in front. I connected it, and look, at this moment, 229 volts AC is coming here, which is absolutely correct. This means there is no problem with our power supply. I connected line and neutral again. Now it's okay. I think maybe there was some issue in my settings. Up to this point, the power is completely okay. Now what we will do is turn the PCB upside down. After turning it upside down, we will further check the power to see whether electricity is properly reaching all positions or not. So here, a bridge rectifier is installed. Let's check it. Here you can see that the voltages change. 90 volts are coming at this position. What we will do is, look here, a line filter is installed. So we will check on this line filter, both before it and after it. We will check at both positions. Now, this PT106, this is our neutral here. Similarly, look at this, PT102, this point is our line. Let's check this point. Look, 220 volts are reaching here. Now what we will do is check on the other side of the filter, at the output. So look, as soon as the system goes to the output side, the voltages change. 9.5 volts are coming. This means there's a fault in this PCB. There could be some kind of short circuit in it due to which this problem is occurring. Now I remove the power from the PCB. Turned it off, we will remove the wire. Now these 2 points are of the capacitor, so we will discharge them, so that if any charge is present in it, it gets eliminated. And this short circuit in the PCB, I think it is on the high side, because the high side is causing the problem. Normally what happens is that if the bridge rectifier is faulty, the PCB does not behave like this. Instead, it trips the main electrical breaker. So I think it is completely fine. There is no problem in it, because the breaker is not tripping. Look, this is showing a proper voltage drop. Let's check the second one. This is also fine. And let's check the last one. This is also fine. So this means the voltage drop here is correct, and the bridge rectifier is completely fine. If this capacitor is short, then it can also cause a problem. So we will check it here as well. It is showing a voltage drop here, which is not correct. It should disappear. Now I have changed the polarity of the probe. Now it has disappeared. Here, look, the IGBTs or MOSFETs are installed here. Now let's check them in diode mode. Look, it is showing a voltage drop here. Now let's check from this point. This is also showing a 2.8 volt voltage drop. Now let's check with this one as well. This is also showing a voltage drop. This means they are completely fine. Now let's check this one. Look at this. In my opinion, either the source and drain are shorted. Look, it should not be short here. It is beeping, whereas this one is showing a voltage drop. This means this MOSFET is fine, and this MOSFET is faulty. It is showing a short circuit. Look, this one also has a voltage drop. There is also a voltage drop showing between its gate and source. This one also has a voltage drop. There is also a voltage drop showing between its gate and source. Now we will check this point again in diode mode to see if there is a short circuit here. Now look here. A voltage drop appeared and then disappeared. Let's check by changing the polarity. This is completely fine. This means there is no short circuit in it. We will hold it here. Now let's check its source and drain. Yes, absolutely. The source and drain are shorted. Now if we look at the number of this MOSFET, it is TYT5. So this MOSFET is installed in it. Now the MOSFET that I removed from here, the same MOSFET should be installed here. If the same MOSFET is not used, then what will happen is that if we install a MOSFET of a different number, it may not function properly in the system. So what we will do is install identical MOSFETs here. Right now, since I don't have this MOSFET number available, our only option is that we have to change all the MOSFETs installed here. Now I have this other number, so we will install this MOSFET here. And when we change them, our system will work properly. Otherwise, if we install a MOSFET of a different number, it may not work properly. Now I have this other number, so we will install this MOSFET here. Now we will check it again and see if there is a short here. So look, now the voltage drop here is 0.46 and also here. So this system is completely fine now. There is no issue in it anymore. Now we will supply power to it and see whether it works or not. I have supplied power and look, its D201 LED has started working here. This means that this PCB is now powered on. I will turn it off. Now, I will supply power to it again. I have supplied the power and will wait for a while. Yes, the compressor has started. So this PCB is completely fixed. Now one thing to note here is that as soon as the compressor started, the D201 LED has turned off and the compressor here has started running. So this PCB is completely okay. And as soon as I turned it off, look, the LED turns on again. Now when the power goes off, it will turn off. Alright? Now we will look at its wiring connections. So the points available here at the moment, look here, OLP, neutral. And these 2 points are for neutral. Similarly, this is L, line. And 1 or 2 points here as well. Look, on this side it is neutral, and on this side it is line. And similarly, this is the signal to start the compressor. Now, I will explain to you how I have made its connections here. So on the power supply, that is on the line, we will connect the line L. So it is connected here, and look, there is a fuse F100 here. This is a 5 ampere fuse, which comes at this point. And this point goes inside the refrigerator and comes back from the thermostat to this point. So when the thermostat turns on and off, this point turns on and off, which starts and stops the compressor. After this, the neutral is connected here. So look at the neutral, one point where the power comes in here, then another point goes inside, and sometimes loops back, or it comes from the refrigerator to this point, at OLP. So in this way, the system operates. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.